Today we're here, and in 8 weeks, we'll reach the solstice point, which marks the start of the summer. Every day, the sun seems to climb a little higher in the sky. On the day of the solstice, it will stop climbing and begin to drop. At the moment, as we cover this stage of our annual orbit, the northern half of the Earth leans a little more towards the sun every day. In winter, the rays of the sun arrived at the shallow angle. Now they reach us from a higher position. It's warmer. The sun is a star, and it's been shining for billions of years. Because its radiation is relatively stable, our atmosphere was able to appear, and life emerge and evolve. Life depends on how far we are from the sun. If the Earth were as close to the sun as Venus, it would be too hot. The heat there could melt lead. And far away from the sun like Saturn, it would be too cold. The Earth spinning on its axis also plays a part in this unique balance. If the Earth turned more slowly, the days would be longer. During the day, the sun would heat us up too much, and at night the temperature would fall too far. If the Earth turned much faster, the atmosphere, the air we breathe, would escape into space, thrown off by centrifugal forces. This balance makes possible our unique and fragile existence in the solar system. Like every other planet, the Earth has a distinct orbit, balanced between the forces of gravity acting on it. Our planet's stability is increased by the Moon. Without it, the Earth would wobble too much to have a stable, livable climate. The Moon is gripped by the Earth's strong pull, which stops it from turning freely. And in turn, the Moon stabilizes the Earth, much as a pole balances a tightrope walker. The giant planets Saturn and Jupiter reduce our risks of colliding with asteroids and comets. Jupiter's enormous mass captured the Schumacher-Levy comet. If it had crashed down on Earth instead of being caught by Jupiter, we wouldn't be here to talk about it. The sun's rays supply each square meter of Earth with as much energy as a dozen 100-watt light bulbs. The sun heats the air. At the equator, hot air, lighter than cold air, rises and begins to flow to the north and south. But the Earth turns fastest at the equator, so the masses of air are deviated in the direction of the Earth's rotation before sinking to the surface and returning to the equator. These are the trade winds. Outside the tropics, the sun supplies less heat. The rotation of the Earth pulls along the masses of air. It's here that the great streams of westerly winds are formed, the ones you often see on weather maps. As they drift to the north and south, the clouds twist into spirals, because the Earth turns more slowly at the poles than at the equator. That's why the clouds spiral anti-clockwise in the northern hemisphere, while in the southern hemisphere they turn the other way. That's how the winds carry the heat from tropical zones towards the temperate zones and spreads the sun's energy over the planet. At this time of year, because of its tilted axis, the Earth's northern half is leaning towards the sun and warming up. It's spring. Each year, the cycle of the seasons repeats itself with only slight differences. But in the long term, the Earth's climate is changing. The sun's rays control our climate. We think there's a 26,000-year cycle linked to the gravitational forces of the sun, which tends to straighten the tilted axis of the Earth. But the inertia of the Earth acts to keep its movement stable. The struggle between these two forces makes the Earth wobble very, very slowly. Over tens of thousands of years, the sun's rays reach us at different angles. and that can change the climate. The ice of the North Pole can invade all of Europe and North America. These are the ice ages. And then these same regions can become tropical. The Earth's climate has gone through tremendous changes. In the beginning, the only life on Earth was in the seas. For millions of years, solar energy manufactured a mixture of nitrogen and oxygen on the Earth's surface. And this mixture is the air we breathe. So it might be a little conceited to say that the slight rise in temperature over the last few years is the fault of mankind alone, when we hardly know how our main heater, the sun, works. The nearest planet to the sun is Mercury. It turns so fast that it lines up with the sun every 4 months. You'd imagine we'd see it pass in front of the sun every 4 months. But Mercury's orbit is slightly tilted compared to the Earth's, and it usually passes a little above or below the sun when we watch it from Earth. But once every 7 years on average, you'll see little Mercury passing in front of the colossal sun. There's another planet faster than us on its orbit, Venus. Every time it catches up, we ought to see it passing between us and the sun. But Venus's orbit, too, is slightly tilted compared to ours. Perfect alignment, when we see Venus passing in front of the sun, only happens twice in a century. That's the order and disorder of the universe. What seem to be perfect circles, fixed for eternity, are ellipses which wobble, waver, and swing. The solar system sways and waddles as if it were alive.